Hello everyone, this is a free online tutorial for the new SAT Math section. This is problem number 16 found in practice test 6, section 3, no calculator. And this is a grid-in question. It says if a raised to the power of b over 4 is equal to 16 for positive integers a and b, what is one possible value of b? Okay, so that means the way this question is formulated, you can tell that there are many possible correct answers here for the values of b. Okay, and also that means that there are also many values of a that you can use, right? Because for different values of b, you will have to use different values of a. Otherwise, it's going to be just one value of b if we know what a means. Okay, if we know what a is, but we don't know what a is. But so we're going to experiment with many different values of a, and then see what we get for the b. Okay. So these are just references that I provide before we play around with A's and find B's after that. So you must know that when you're dealing with exponents, 16 can be expressed using the bases multiplied by themselves 3 times, right? So it's going to be 1, 2, 3. So we can express 2 times 2 times 2 times 2, which is equal to 16, as 2 raised to the 4th power, right? Because there are 4 2's here. The power represents the number of times you see a base in a multiplication. Even though the base multiplies itself 3 times, 1, 2, 3, but there are four instances when this number appears, this base, right? So it must be 4 as a power, okay? Now, the same way, similarly, 16 can be expressed as a multiplication involving the base 4. Okay, so if you play around with the base 4, you will have 4 times 4, and that's going to be equal to 4 raised to the 2nd power. Now, you must know that 16 can be easily expressed as 16 to the power of 1. Okay, so now we're ready to play around with possible values of a, and then find their respective b values for those possible values of a. Okay. So let's set a is equal to 2. Now be careful that you read this thoroughly. It says positive integers a and b, right? So a can be positive and it must be an integer. Okay, so we start with the simplest base 2, right? Because we can't have a is equal to 1. Because if you raise 1 to any power whatsoever, it will only give you 1. There's no way that you can transform 1 into a 16 if you have 1 as a base, right? 1 as a base will always give you a 1 no matter what you do. Okay, so we start with this is the smallest value of a that we can use, 2, right? The smallest integer value of a greater than 1. Okay, so a is equal to 2. When a is equal to 2, and keep in mind that a is the base, right? So we must set the base a is equal to 2, and also remember, if you want to play around with your b's and find your b's, you have to set the 16 as a base to a certain power, and the base must be the same as the value of a that you choose. Okay, so if we choose the value of a as 2 here, we must include the same 2 as the base on the right side of the equation and express this base of 2 raised to a certain power to give us 16, right? So we have 2 raised to the power of b over 4 is equal to 2 raised to the power of 4, right? Because what do we have to do to 2 to get it to be 16? To get it to be 16, we have to have a power of 4, right? So 2 raised to the power of 4 will give you 16, and that's why I introduced these reference equations here for you. Okay, so 2 raised to the power of 4. So that means if your bases are the same, you can set their powers equal. Okay, that's the rule. First you set the bases equal, and then you set their respective powers equal, right? So we're ready to set b over 4 is equal to 4. Now if you multiply both sides by 4, b is equal to 16. Bingo, that's your first possible value of b. Now the next the next value of a. So let's set a is equal to 4, and using the reference here, when 4 is the base, 16 can be expressed as 4 squared, right? So we're going to have 4, remember the bases must be the same, so 4 raised to the power of b over 4 is equal to 4 squared, right? Because 4 squared is 16. Okay, so now we're ready to play around with the b again. So b over 4, setting the powers equal again, since the bases are the same, b over 4 is equal to 2. And multiplying both sides by 4 again gives us, this time, b is equal to 8. Bingo, that's the second one. Okay? Now, let's keep going. And notice how we play around with the values of a. We multiply by 2, and then we multiply by sorry, we take, notice that a is equal to 4. That's the square of the 2, right? Because 2 squared is 4 and 4 squared is 16. So we're going to keep going this way. It's like a pattern here that you notice. Okay, so set a is equal to 16 now, and remember, once again, using this reference here, 16 can be expressed as 16 to the first power, right? So 16 will be the base now. 16 raised to the b over 4 power is equal to 16 raised to the first power. And now we're ready to play around with the b's again. b over 4 is equal to 1. Multiplying both sides by 4 gives us b is equal to 4. Bingo, that's the third possible value of a b. And notice what happens to your b's as you keep going with different values of a. So as a progresses to the next one by squaring the previous a values, right? Square of 2 is 4, 4 squared is 16. The next will be 16 squared. The b's are divided by 2. See that? 16 over 2 is 8. 8 over 2 is 4. I mean, you could actually theoretically go there. I mean, you could already tell that the next b will be 2 and the next b after that will be 1. You know that, right? And so you will have five possible values of b. I mean, this is just for the sake of fun in mathematics, for the sake of having fun with your exponents, right? But let's keep going to check if this is true, if the pattern will eventually lead to b is equal to 2 and b is equal to 1. So let's keep going. So a is equal to 16 squared, right? Because we're squaring the previous a, as it turns out in this pattern. Okay? So a is 16 squared will be the new base. Okay? So now 16 squared is the base raised to the power of b over 4 is equal to 16 squared raised to the power of 1/2. Now you must know that if you have parentheses and you have powers outside on one side of the parentheses, they're simply multiplied. And 2 times 1/2 is 1. Bingo. So this is the concept of having 16 on the right side of the equation is not violated, right? So 16 squared raised to the power of 1/2 gives you 16. So now you're ready to play around with your b's again. b over 4 is equal to 1/2 because the bases are the same. 16 squared are the bases, right? And the powers are b over 4 and 1/2. So b over 4 is equal to 1/2. Bingo. Multiplying both sides by 4 gives you b is equal to 2 because 4 over 2 is 2. Bingo. Look, our prognosis makes sense because b keeps being reduced by 1/2 each time, right, as we go on. So b is equal to 4, b is equal to 2. So the next one, you know, b is equal to 1 will be the next one, right? But let's see, let's have fun and see how this works. Next a value is going to be the square of that, right? Because 16 squared, if you square that, it's going to be 16 raised to the 4th power, right? So that's going to be your new base. That's going to be your last base, right? Because you can't go less than b is equal to 1 because in the problem it says positive integers a and b, right? So we cannot go less than 1 for the b. So a is equal to 16 raised to the power of 4. That's going to be the final base that you're going to use for a. 16 raised to the power of 4 raised to the power of b over 4 is equal to 16 raised to the power of 4 raised to the power of 1/4, right? Because again, when you multiply on both sides of the parentheses, the powers, they just multiply themselves, right? You don't add them. Make sure you know this rule. You multiply them, okay? So now, 4 times 1/4 is 1, right? Because 4 times 1/4 is 4 divided by 4. And that's 1. And that's 16, right? Doesn't violate the fact that 16 needs to be on the right side. Okay? So now we're ready to play around with the b's one and final time. You know, I'm getting tired with my voice here, but I need to finish this problem for you guys. So b over 4 is equal to 1/4. And that's very easy, right? Multiply both sides by 4. b is equal to 1. Bingo. Very good, right? So we have possible answers for the b. 1, 2, 4, 8, 16. 1, 2, 4, 8, 16.